Come, someone give me idea. Is it okay handing your MS2 next week? The one whole week I... Who's that?
Me, Vanessa. I agree.
Yeah, Vanessa.
Okay, teacher. Can hand in next week.
Okay. So when next week, I give the from Monday to Thursday. Then Friday I will come and collect.
Okay,
Okay.
teacher.
If you send after Friday, then very difficult. I will not come to school already. Then maybe will be school reopen. Your book is still at the guardhouse or not. Because when school reopen, also 1 week, I will not come to school. Okay, I have something on. Okay, so if next Friday, before next Friday, you can hand in. But start from Friday onwards, you don't hand in anymore. Okay, and then when you come to hand in, please take back your MX1. Okay, I will put at the guardhouse. Okay, so you come and hand in your MX2 at the guardhouse and take back your MX1. Okay, tell your parents. Okay, so want to present. Okay, so today we will start chapter 3. Okay, can see the screen?
Yes, teacher.
And okay, so chapter 3 is integrations. Okay, so actually integration and the differentiations they are brother sister. Okay, so the reverse of the differentiation will be integrations. Okay, so actually quite easy to understand. Okay, so same thing for this chapter 3 also there is none of one formula will be given in the formula list. Okay, so whenever you see that that formula you need to use, then you got to memorize it. Okay. Okay, so first of all, we want to learn integration as the reverse, the inverse of a differentiation. Okay, so this one will be your index for today. Okay, and then since this is chapter 3, so you should use a different book already. So you use MX3. Okay, so this is index for today. Okay, today is a 9. Okay, then use MX3. Okay, we can go through this story. Okay, the photo on the right show a water tank installed at a factory. Okay, water flow out of the tank at the rate of given by. Okay, they know the rate of the water. Okay, dV over dt. V is volume. Okay, where the V is the volume in a meter cube and the T is the time in hour. Okay, so they know the rate the water flow out of the tank. Okay, the tank will be emptied within 5 hours. Okay, with this rate of water used from the tank, can we determine the volume of the water in the tank at a certain time? Okay, why we can't we don't know the volume of the water is because you look at the shape of this water tank. This shape if all the solid geometry that you have learned none of it is how to say can fit for this shape lah. Okay, so this one you want to find the volume you can't use it you can't use the formula to get the volume now. Okay, so how you want to get the volume okay, one way is if you know okay the water rate, okay, the water flow out rate, then from here actually you can get the volume. Okay, so by using these integrations. Okay, so we continue the relation between differentiation and integration. Okay, we have learned how to differentiate a given functions y equal fx. Consider the functions y equal 3x squared plus 4x plus 5. Okay, then we get dy dx. Okay, so you differentiate this, you differentiate 3x squared, you get 3 times 2, 6x. You differentiate 4x, you get 4. You differentiate 5, you get nothing, you get 0. Okay, therefore dy dx is 6x plus plus 4. Okay, then integration is a process which is quite similar to differentiation, but is denoted by the symbol this. This one is like a longer s the way you write like a s, but it's a longer s. Okay, and then here you put the functions that you want to integrate, and then you must remember to write dx. This one means integrate with respect to x. Okay, like this we call it differentiate with respect to x. Then this one we call it integrate with respect to x. Okay, what is the relation between differentiation and integrations? Okay. Okay, this part maybe you want to recall a bit. Okay, when you differentiate ax, example 5x, 3x, okay, 10x, okay, then your answer is the a. Okay, when you differentiate a, example you differentiate 5, okay, you differentiate 10, then your answer is 0. Okay, and then if you differentiate this kind of function, ax to power n, then your answer will be a n and then x, okay, and then power n minus 1. Okay, this one is what you have learned for the chapter 2. Okay, we go down. This one I will skip. Okay, so you see just now that symbol, this symbol. Okay, so you have mathematicians, German mathematician. I don't know how to read the name. Gottfried. Okay, so it's a German mathematicians. Okay, introduce this symbol. Okay, the integral symbol. Okay, so actually this is like a long S. Okay, so we want to see, okay, what is the relation in between the differentiation and integrations? Okay, we go to this part. Okay. Okay, so actually the integration is the reverse process of differentiations. Okay, so this one I don't want to go through. Okay, this one actually I skipped that one. Okay, just very fast. Okay, so from the fx you differentiate. Okay, you get f prime x. From the f prime x you want to get back fx, you do integration. Okay, this process we call it in reverse. Okay, reverse of the differentiation. Okay, after I give you some example, then you will see clearer. Okay, so you look at this. Okay, if you differentiate fx, you get f prime x. Then you integrate f prime x, you will get back fx. Okay, so this is the one. Okay, then we look at this. Okay, we differentiate this. Okay, but this is given now. Okay, we differentiate this, we get 8x. Okay, so it followed just now. Okay, saying that integration is the reverse process of differentiation, means when you integrate 8x, you should get back this. Okay, so your answer is 4x squared. Okay, that's simple. Okay, so I repeat, you differentiate 4x squared, you get 8x. So if integrate 8x, you should get back 4x squared. Okay, so this is the meaning of reverse of differentiation. Okay, we look at one more example here. Okay, the coal production from a coal mine is given by this. Okay, where K is the mass of a coal produced in tons and T is the time in years. Okay, find the rate of production of coal dk over dt in terms of the T. Okay, so first of all, you differentiate this. Okay, so you differentiate this, what do you get? Can I call someone? Okay, Sarah. Can Sarah help me? Sarah here? Sarah? I see you on your mic, but I can't hear you.
Teacher, can you hear me already?
Okay. Okay, cool. We come back here. Wait, sorry. Okay, can you help me to differentiate the K with respect to T? The K is given here, this.
48,000
48,000
minus 300 t squared.
and 300 t squared. Okay, thank you. Okay, so I give you 1 mark here. Okay, so this is a part A. Okay, it's done. Okay, now we go to part B. Okay, if the rate of productions of coal is given by this, okay, find the mass of coal produced in tons in the 4th year. Okay, so how you relate this and the A? How you relate this dk dt with the A punya dk dt? Okay, can you see this is 3, this is 6. Assume that this is times 2. This one times 2. Try and see 48,000 times 2, do you get 96,000? 48 times 2, 96. Okay, so correct. Okay, therefore, this dk dt for the part B, okay, this you can, this one you can write it in this way. 48,300. Okay, because after I'm going to make use of this. Okay, I'm going to make use of this. Okay, so you see, okay, now I want to find the K. Okay, the mass of the coal. Okay, they want you to find K. So what I'm going to do is, you have learned this is a reverse of the differentiation. So means you integrate this. This is from the part A. You integrate this, okay, with respect to t. Okay, you should get back, okay, the original functions. 48000t minus 100t to the power 3. Okay, this is the meaning. But this is for the A. The B got a little bit different. Okay, for the B is this. If I want to integrate this, okay, but actually the same thing. You can just put the 2 outside. So actually, after we're going to learn also. I don't know whether it's today or not lah. Okay. Therefore, continue here. Okay, this part is this. Okay, so I'm going to copy this. 48,103. Okay, so this is the answer for the K. This is the answer for the K for the part B. Okay, for the part B. Okay, okay, but not yet. Okay, they want it in the 4th year. Okay, they want it in the 4th year. So for in the 4th year, you got to substitute t equals to 4. Okay, the t is in year. Okay, correct. Okay, so when t is 4, okay, then find the k. 48,000. Okay, substitute t as 4. 100, substitute t as 4 power 3. Okay, that answer. Okay. The answer it should be this. I copy from the book. Let me check. 6400. 6400. 48,000 times 4 minus 6400 times 2. Okay, correct. So this is a 1. Okay, then we come back here a little bit. Okay, we go through this. Okay, give 3 examples in daily life that can illustrate that integration is the reverse of differentiation. So just now we have the water tank example, then we have this co-productions example. Okay, 2 example already. Okay, so I just call out the answer. Okay, we just see the answer. This is 33. Okay, here you have 3 more example. Okay. Okay, this one. Okay, the first one, find the volume of water in a from the rate of a water flow from the pipe. Okay, this one quite similar to just now. The volume for the water tank. Okay, number 2, find the distance traveled by an object from the rate of change of distance or speed. Okay, rate of change of distance actually is a speed lah. Okay, so from the speed, you do the integration, you can get the distance. Okay, because speed actually is d. Let's say distance is s so it's ds over dt lor. Okay, so you integrate, you will get back the distance. Okay, number 3, find the area of a reproduction of mole from the rate of increase of area of the mole on the break. Okay, so you have anything you have the rate of change. Actually you can get back the how to say, in this case this is the rate of change of the area. So by doing integration you will get back the area lor. Okay, so that's all for this. Okay, I come back to the textbook. Okay, so today you can do this exercise. This formative exercise we hold on first. I don't know if afterwards too not too many questions, then I will give you lah. I will ask you to do. If not, then we just leave it first. God, I scared at the end too many questions for you. Okay, next we're going to do this. Okay. Okay, this one is we integrate. Okay, we integrate for follow the formula. So we want to investigate what is the integral formula. Okay, so for the integrations, actually there are 2. Okay, one we call it indefinite integrate. Okay, indefinite integration, and then the other one is a definite integrations. For definite integrations, the final answer is a value, because we will substitute the upper limit and the lower limit inside the functions that we get after the integrations. But for indefinite integrations, the final answer is a function. Okay, it's not a value. Okay, because we didn't substitute the value inside the functions. Okay, so today I think I can do only the indefinite integrations. Definite integrations, I think it will be another day. Okay, so we go through this activity. Discovery activity 2. Okay, I want to show you this. Okay, where? Okay, here's my cursor. Okay. Okay. Okay, look at this. Okay, this is for the first case. Okay, so first of all, we do the differentiation. Okay, this is the function given. Okay, look at this, the first one. Okay, 2x plus c. C is a constant. It's just a number. Okay, means c can be any number. 1 lah, 2 lah, 3 lah, can be any number for c. Okay, so when we differentiate this, okay, we will get 2. Okay, because when you differentiate c, the any number, you will get 0. Okay, so 2x, when you differentiate, you get 2. Okay, so for this, okay, when you differentiate, you will get 3. Okay, this one, when you differentiate, you get 0.5. Okay, when this one you differentiate, you get -7. This one, when you differentiate, you get -4. Okay, so integrate of this. Okay, the third column will be you integrate of this f prime x. Means this one, when you integrate 2, okay, your answer is 2x plus c. You still remember? It's the reverse. Okay, so when you integrate whatever you have differentiate, okay, you will get back the original functions. Okay, so this one's the same thing. When you integrate 3, okay, you will get 3x plus c. Okay, when you integrate 0.5, okay, then you will get 0.5x plus c. Okay, then when you integrate -7, then you get -7x plus c. Okay, last, when you integrate -4, then you will get -4x plus c. Okay, this is the meaning. So from the case 1, okay, from the case 1, I go back to the textbook. Okay, from the case 1, okay, you will get this. Okay. Okay, means A is a constant. When you integrate a constant, okay, you will get that constant times x plus c. Okay, is you do by inductions from this table. Okay, inductions from this table. Okay, when you integrate a constant, okay, with respect to x, you will get that constant. Okay, here is 2 lah, that constant. So if here is a, then this is a lor. So ax plus c. Okay, this is the meaning. Okay, so when you integrate 10 with respect to x, you will get 10x plus c. Okay, this is the meaning. So this is the first formula that you got to memorize. Okay, you got to remember this. Okay, now we go to the second one. Okay, second one is more complicated. Okay, so second one, we do the same thing. Okay, so first of all, I'm going to do a differentiation. Okay, I differentiate this. I can call someone to help me. Aksa here. So every day I've been calling Aksa lah. Okay, because I really want to help you. Someone put the message here. My connection is unstable. I might leave and come again. Okay, it's okay, Kritika. Okay. Is Aksa here? Yesterday, I think I missed one more girl that Ravania. Aksa and Ravania. Before I call Sherlyn. Aksa and Ravania. Anyone can give me response? Aksa and Ravania. Anyone can give me response? Hey, someone have responded. Okay, Ravania, very good. Can you help me to differentiate this? I want to give you 1 mark. Okay, you help me with this. Okay, Ravania, can see the screen. Okay, help me with this, the second functions. Differentiate this. Differentiate 2x to the power 3 plus c. You can write in the chat. Ravania, if you cannot, then you just answer me. You can't do. Okay. If you cannot do this, means the whole chapter 2 will have problem. If your whole chapter 2 cannot do, means your chapter 3 also you cannot do. Ravania, think about it, okay? If really cannot cope, you should drop MS, huh? Okay, so now can I call Sherlyn? If Aksa here, Aksa, you can cut the queue, okay? Sherlyn here or not? Sherlyn. Oh, very soft. Can you talk louder? Oh, wait. Maybe I on my mic, my speaker. Speaker is I talk or you talk? You talk. Okay, you talk again. Oh, very soft. Okay, never mind. I try. Oh, okay. Can you help me to differentiate 2x to power 3 plus c?
6x squared.
Okay, 6x squared. Thank you. 6x squared. Okay, Ravania, see 2 times 3 is 6. Okay, and then x. Then the power 3 here minus 1. So you get 2. Okay, thank you, Sherlyn. The next girl will be Shuda. Shuda here already, yeah? Sudah belum ada wah. Okay. Yesterday she also didn't come. Okay, she say she tertidur. Okay, Shilanya.
Yes, teacher.
Come on, I want to give you mark. Okay, help me.
8x cubed.
8?
8x cubed.
Okay, 8x cubed. Now, you see, so easy to get 1 mark. Okay, Sonia 3 here already. Sonia 3, belum, tak ada. Okay, Theo here.
Yes, teacher.
来, come, I want to give you 1 mark. Okay, 2x to power 5.
10x to the power of 4.
Okay, 10x 4. Okay, last one. Anik. Anik here.
12x to the power of 5.
Thank you. Okay, this is 12x to the power 5. Oh, you're waiting to answer my questions already. Very good. Then we can go very fast. Okay, so I also give you 1 mark. Okay, the rest I tak tahu already. Hiya. I don't understand Aksa lor. She's here, but she's not here. She is here, but she is not here. Okay, so we come back here. For the third column, we will do just like just now. Okay, when you integrate what you have differentiated just now, you will get back the original function. So I copy here. Okay, when you integrate 6x squared dx, okay, you are getting 2x3 plus c. Okay, then this 2x3 plus c I'm going to write in this way. Okay, x3 over 3, then this is, how am I going to write? Wait, let me think. This is 3, because I want to get the power here. If this is 3, this one should be 6. This one should be 6. This one should be 6. Correct? 2. Okay, correct. Okay, this one is I want to write in this pattern. Okay, so that after by inductions I can come up with a certain pattern. Then only we can make the conclusion for the formula for the integrations. Okay, so you see the 3 and the 6 I cut, I still get back 2 lor. I still get back 2. Okay, for the third one, okay, when I integrate 8x to power 3 dx, I will get back 2x4 plus c. Okay, again, this one I'm going to write as x to power 4. Then here is 4. Then here is 8 plus c. Okay, the next, okay, integrate 10 x to power 4 dx is equal to 2x5 plus c. Okay, this one I'm going to write in this way, x to power 5, here is 5, here is 10, okay, plus c. Okay, last one, I integrate 12x5 dx is equal to 2x6 plus c. 2x6 plus c I'm going to write in this way, x to the power 6, here 6, here 12, then plus c. Okay? Now we want to analyze the pattern. Okay, so instead of the 2 and the 2, they write as 1 plus 1. 1 plus 1 is because here, this is 1. Okay, so here the same thing, I'm going to write it as 6 and then 2 plus 1 because here is 2. Because here is 2. I'm going to write it as 2 plus 1. Then the 3 at the bottom also I'm going to write it as 2 plus 1. Okay, next. Okay, so this one is 3. Therefore, I'm going to write it as 3 plus 1. Then here also same thing, 3 plus 1. Okay, next, this is 4. So this one I'm going to write it as 4 plus 1 and then 4 plus 1. Okay, last already. Okay, this one is 5. So I'm going to write it as 5 plus 1. Then here is 5 plus 1. Okay, therefore, okay, I can make these conclusions if I integrate a x to power n dx. Okay, if I integrate, example this, okay, the a will be this 6, the n will be this. Okay, so my answer is what? Still get back 6. 6. So is n. So not a, n is a. Okay, and then x. Okay, then n plus 1 because 2 plus 1 here, so n plus 1. Okay, over 2 plus 1 again, so it's n plus 1 again. Therefore, I get the formula. Okay, remember plus c. Okay, so this is the formula. Okay. If you go back to the textbook, you will see the formula here. Okay. This is how we are using the induction method, okay, to analyze, to see the patterns, okay, to get the formula for this a x to the power n. Okay, a and c are constant. Okay, n is an integer. Okay, and then n cannot take -1. Okay, why you cannot take -1 is because here, -1 plus 1, you get 0. The denominator cannot be 0. Okay, therefore, n we never take for -1. Okay. Okay, so we continue. Okay, in general, the functions ax plus c. Okay, ax plus c, this one, and this one, ax to the power n plus 1 over n plus 1 plus c are known as indefinite integral for constant a with respect to x and function ax power n with respect to x respectively. Okay, so means when you have this, when you integrate this, okay, with respect to x, you get this. Okay, when you integrate this with respect to x, you get this. Okay. Now we see some of the example here. Okay, this is another story idea. Okay, we have finished for this. Now we want to discuss about the c. Okay, why you need this c and then why you have that c. Okay, you look at these 3 cases. Okay, first case, y equals to 5x. Okay, dy dx is 5. Okay, when you integrate 5, okay, you get back 5x here. Okay, case number 2. Okay, y equals to 5x plus 2. Okay, dy dx is 5. It's still 5. Okay, but when you integrate this, you get back this. Okay, for case number 3. Okay, 5x minus 3. Your dy dx is still 5. Okay, but you integrate this, follow this case, you get back 5x minus 3. Can you see this? When you integrate 5, integrate 5, integrate 5, but why you have different answer? 5x, this one plus 0 lah, let's say. 5x plus 2. Then 5x minus 3. Why you have a different answer? Although here the 5x, this one is the same. This one is the same. This one is the same. Okay? Therefore, you need to, for the integration, you need to have this plus c. Because this c can be different. When you have at the different point, okay, you will have a different c. Okay? Or for the different case, you have a different c. Okay? Therefore, if we don't know the original, we don't know this, we don't know this. This one we don't know. This one we don't know. This one we don't know. We just start with this. We just start with this. Then how do I know? It should be minus 3 lah, plus 2 lah, or plus 0. I don't know. Therefore, I need to plus c. So always for the indefinite integral, you will see this plus c, plus c. So remember, don't just integrate. Remember to add a plus c at the back. It's because of this. Okay? We don't know the original functions. Okay? So after the integration, they will have some constant. Okay, it's either maybe 0, you know, or other number. Okay, so you got to plus c for the integrations, indefinite integrations. Okay, so this is explain why you need to plus c. Okay, I still have 15 minutes. Agak 15 minutes. Okay, I have a few more examples. Okay, notice that differentiating. Okay, those three cases give a same value of dy dx, even though each of them has a different constant. Okay, this constant is known as the constant of integration. Okay, the c lah, and represented by the symbol c. The constant c is added as a part of a indefinite integral for a function. Okay, for example, okay, when you integrate 5 with respect to x, your answer is not just 5x, it should be 5x plus c. Okay, so now we look at some example. Indefinite integral for algebraic functions. The infinite integral formula can be used to find infinite integral of a constant or an algebraic functions. Okay, so now we look at this. Okay, integrate each of the following with respect to x. Same thing, when you see this type of questions, you don't write formula this way. 12 is equal to 12x plus c. Oh, what is the meaning of this? What's the meaning of this? Okay, no, don't write in this way, because the question say integrate with respect to x. So write this, write the long s, integrate 12 with respect to x, then only the answer. Okay, so the 12 is the constant, so we follow just now that first formula. Okay, so this is the a. Okay, so for integrate a, okay, your answer is ax plus c, so it's 12x plus c. Integrate half, your answer is half x plus c. Integrate negative 0.5, your answer is negative 0.5x plus c. Okay, so this is the first one. Okay, this one just now also we mentioned already. Okay, the previous you got one example. So if you have a here, okay, so the a actually you cannot take out. Okay, take out the a. So you just do this part. Okay. Okay, find the indefinite. Find the indefinite integral for each of the following. Okay, so this one we follow the second formula. Okay, this is how you do. Okay, when you integrate x to power 3, okay, so you add to the power, okay, add to the power 1. Okay, so here is 3, so 3 plus 1, then over that power. Okay, so over the 3 plus 1. Okay, so you see for differentiation, you are decreasing the power by 1. For integration, terbalik, okay, you are increasing the power by 1. This is how you remember. Okay, so you plus 1 to the power and then divide by whatever the after the plus 1 for the power. So 3 plus 1 here. Okay, so this is the answer. Okay, how about this? This one, you can drag out the 2 outside it. Okay, so just put it outside. So you only concentrate to integrate this. Okay, so x to power -2, same thing, plus 1 for the power, and then divide by whatever the power for after the plus 1. So this is the answer. -2 plus 1 is -1. Okay, -2 plus 1 is -1, so you have a negative here. Okay, then you write back in this way. Okay, so this is for the second formula. Okay, we do a few questions here. Okay, find the integral for each of the following. Okay, what is this? Okay, here in between got nothing. This one means 1. The 1 they didn't write. Okay, you integrate 1. So you integrate 1 using the first formula. Okay, your answer is 1x plus c. Therefore, it's x plus c. Okay, we go to B. Okay, you integrate 0. Okay, use the first formula. Your answer is 0x plus c. Okay, 0 times x, you get 0. Therefore, your answer is C. Okay, this is some special case lah, huh? Okay, this one. Okay, integrate a modulus of x. Okay, with respect to x. Okay, so for this part, remember modulus, there are 2 meaning. Okay, there are 2 meaning for modulus. So first meaning is positive. Okay, when x is positive or equal to 0. Okay, the other meaning is negative when x is smaller than 0. This one you have learned during your form 4, huh? Okay, when x is smaller than 0 means x itself is negative, then this negative and negative will bring the whole thing become positive. This is the meaning of the modulus. Okay, after this negative and this negative, it will come back to a positive. Okay, so how to integrate the first one? X means the power is 1. The power is 1. So by integrate it, 1 plus 1 is 2, then over 2. Okay, remember plus c. Okay, so this is for this case. Okay, then negative, put aside, then do the same thing, 2 over 2 plus c. Okay, this is for when x is smaller than 0. Okay, so that's all for these 3 examples over here. These 3 are special case. Okay, we continue a bit more. Okay, in the chapters of differentiation, we have learned the method of differentiating a function such as hx 3x squared plus 5x by expressing fx equals to 3x squared and gx equals to 5x. Means we differentiate term by terms. Okay, so for the integration the same way, we also can integrate term by terms. Okay, when this is a algebraic expressions more than one term. Right. Okay, a similar approach will be used to find the integral for function with addition and subtraction of algebraic terms. Okay, if fx and gx are function, then this one apply. Okay, so this one you can say this is an addition or subtraction rules, but seldom Okay, it's just automatic. When we see this, we will do it term by term. Okay, let us see the first one. Okay, let us see the first one. Maybe I do for you. Okay, go to okay, this is example 5. Okay, this is A. So the question is 3x squared plus 2. Okay, so term by terms. So for the first term, I'm going to integrate 3x squared with respect to x. Okay, so remember the 3, you can just write back the 3. So I only concentrate this. Okay, Power plus 1, so it's 3. Remember, over the power, 3. Okay. Then when you integrate a constant, remember the answer is that constant times x. Okay. Remember plus c at the end. So x equals 3, 2x plus c. Okay. After simplifying, this is the answer. Okay. Now we go to part B. Okay, this is the questions. Okay, so here you see is times are in between. So you want to you have to expand it to make it term by terms. Okay, so I first thing before I do the integration, okay, I got to do the expansion. Okay, this is minus 2, this is plus 6. So 6 minus 2, so positive 4x. Okay, now I can do the integration term by terms. Okay, so first term, okay, power 2, 2 plus 1 is 3 over 3. The 4 just write back. Okay, this one means power 1. 1 plus 1 is 2, then over 2. Okay, this is constant. So remember, when you are integrate constant, is the constant times the x. Remember last plus c. Okay, simplify. Okay, write in this way. Okay. So this is the answer for B. Now we go to C. Sorry, this is 2. Okay, same thing. This one you have to expand first. Okay, so first of all, first term 3 times so 3x squared. Okay, then x2 and x5. Okay, so 2 minus 5, the index, because this is over 2 minus 5, so the index is negative 3. 2 minus 5, negative 3. Okay, dx. Okay, so integrate it. Okay, so the 3 just write back. Okay, the power plus 1, so 3 over the power. Okay, so here the same thing, negative 3 plus 1, so it's negative 2. Okay, over negative 2, remember plus c. Okay, simplify. Here negative, the negative you have to write it here, or 1 over, the 2 is at the bottom. This one negative, so right at the bottom, plus c. Okay, so this is the answer. Okay, 6 more minutes. Okay, we come back to the textbook. So I hope I have shown you a few examples, then you can do it already. Okay, so this one is your homework. Okay, maybe we can discuss a bit about this. Okay, integration of functions containing algebraic terms added or subtracted together will have only one constant of integration. Okay, why? Okay, you can discuss it. Okay, this is the meaning. You see, actually, yeah, you see they do it the integration term by terms. Okay, so actually for this one, you are getting, and then actually you should write plus c. Then for this one, you are getting 2x and then plus c also. Okay, so you see this c add out you still will be c. Why c plus c is not 2c leh? Maybe you will ask this way. Okay, how about I don't label this as c? Okay, I label this is c1. I label this is c2. Okay, so my c here actually is from the combination of the c1 and c2. So I just write 1c is enough lah. Okay, so I don't write for 2c. I don't write here is plus 2c, because you will say, oh, here got 1c already, here got 1c, then it's 2c. Then here if I doing 3 terms, then 3c. Then here I doing 2 terms, 2c. No, We are not going to write in that way. Okay, you can think in this way. Okay, after the first terms integration, you get maybe this one is we call C1, then this one you call C2, then C1 plus C2, then you write it as a 1C is enough. Okay, because a constant plus another constant, you still get a another constant. Example, this C1 at, let's say is 2, the C2 let's say is 3, so C1 plus C2 you are getting 5. 5 is still a constant, it's just another constant, so you just label is for 1C is enough, no matter how many terms you integrate. Okay, this is the meaning. So I think that's all for today. Okay, I come back to the screen. What's the attendance today? 21 minus Chong 20 minus me 19, so 3 not here. Okay, I didn't assign the homework for yesterday yet. Yesterday I was very busy. Okay, stop recording.